Hello everyone. This video will show how to sketch the graph of functions involving Euler's number e. Now let's go over this example. Looking at the function that we have right here, this resembles that of the transformed form of exponential function, where our a here is the stretch factor and the hk is the locator point. In order that we can sketch this function that we have right here, we need to first determine the horizontal asymptote. Please remember that the horizontal asymptote of this general function that we have here is represented as y equals k, which in this case here, our k is 4. So the equation of the horizontal asymptote is y equals 4. So we can go ahead and sketch this horizontal asymptote down here. The next step that we need to do is to create the table of values so that we can sketch the graph. The first column that we're going to have here will be x. And the second column that we have here will be y equals the parent form for this given function that we have here is y equals e raised to the power x. And the next column that we have here is to get the value for y, which is actually equal to f of x. So we go ahead and put in some values for x first. So we can go ahead and assign x as -1, 0, and 1. So what we do next is we plug these values into this equation right here. So we have y is equal to e raised to the power -1. So e to the -1 is pretty much like 1 over e. So that if you use calculator on this, 1 over e is 0.37. And so we also have e equals, the x here is 0. So e to the 0, any value raised to the power 0 is 1. And then we also have e raised to the power 1 is pretty much like e, which is rounded off to 2.72. For the next column that we have here, we're going to use the stretch factor, which is -3. So what we're going to do is we will multiply -3 to the f of x, meaning whatever this value that we have here, we're going to multiply that with -3. So 0.37 times -3 is -1.11. And then we have -3 times 1 is -3. And then we have -3 times 2.72 is -8.16. Now what we do next is we are going to determine the transformed x values. So in the given equation that we have here, it says x plus 2. So what we write here is we switch it. So that would be x minus 2. So what we do is whatever this value for x right here, we're going to subtract 2 to it. So -1 minus 2 is -3. We also have 0 minus 2 is -2. And then 1 minus 2 is -1. And for the transformed y value, we go ahead and use this value that we got here, which is -3 f of x. And then the k value that we got is 4, so we're going to add 4 to it. Column that we have here represents the value of the function when it is stretched by a factor of -3. So we go ahead and add 4 to each of this. So -1.11 plus 4 is 2.89. And then we have -3 plus 4 is +1. And the -8.16 plus 4 is -4.16. Now, please remember that these last two columns that we have here will be our x and y values. So please notice that the x had been transformed and the y has been transformed as well. So we go ahead and sketch the graph for this. So we start with -3 and 2.83. -2 and 1, -1 and -4.16. So this is the graph of this function that we have right here. So we go ahead and determine the domain and range for this. So the domain for this graph would be all real numbers. All real numbers can be represented as this notation right here, R. If we want this in inequality notation, we can go ahead and rewrite this as x is greater than negative infinity less than positive infinity. Or we can write this in interval notation, that is negative infinity and positive infinity. Now for the range on this graph, so that would be y is less than 4. Or we can go ahead and write this in inequality notation, y is greater than negative infinity and less than 4. Or in interval notation, we can write this as negative infinity all the way to positive 4. Now let's move on to the next example. If you notice, this graph can be written as, since we don't have a value for k, we can go ahead and say that k is equal to 0. This tells us that our horizontal asymptote is y equals 0. So remember that horizontal asymptote is represented as y equals k. Since our k is 0, so our horizontal asymptote is y equals 0. So we go ahead and create the table of values. Okay, so I've set up the table. We pick -1, 0, and 1 for x. You can pick any value, but if you can come up with this, then you should be good. So we go ahead and plug in the value for x into this equation that we have right here, which is the parent equation for this function, and we will be able to solve for y. Now looking at the equation that we have here, our a is 1/4. So we go ahead and use this stretch factor to multiply it with the f of x. So this value for f of x right here will be multiplied by 1/4. So if we do 0.37 times 1/4 or 0.25 is 0.09. And then I will do the same thing for the rest of these values. Now we look at the exponent for this equation. It says x minus 2. So we go ahead and say x plus 2. And then for the y coordinate, we will use the 1/4 f of x here, which is the transformed values for the f of x using the stretch factor. And then we're going to add the k. So that would be 1/4 f of x plus 0. So we go ahead and do the math here. So -1 plus 2 is 1. 0 plus 2 is 2. And then 1 plus 2 is 3. And then we use this number here. And then we're going to add 0 to it. It's not going to change it. Now this will be the coordinates after all the transformations. So we go ahead and sketch the graph of the function. So this is the graph of this function that we have up there. So we're going to go ahead and write the domain for this graph. The domain for this graph would be all real numbers. The range for this graph would be the values of y greater than 0. So these are the ways to write the domain and range for this given function that we have here. Now let's move on to the next example. So this equation that we have right here can be written as y equals 2e raised to the power negative of x minus 3. If you notice, if we distribute the negative to each of the terms inside the parentheses, this is going to be negative times positive is a negative x. Negative times -3 is a positive 3. And then we have a minus 5. Looking at this equation that we have right here, we can go ahead and say that our horizontal asymptote is y equals -5. So we can go ahead and sketch the horizontal asymptote. Now notice that this equation that we have right here can be written as 2 times, since this is e to the exponent of -1, because there's like an invisible 1 right there. So I can go ahead and write that as 1 over e. So that represents e to the -1. And then let's raise to the power x minus 3. And we also have minus 5. So this will be the equation that we're going to use to complete the table of values. So if the simplified equation would come out like this, 2 times 1 over e, then our parent equation would be y equals 1 over e raised to the power x. So what are we going to do next is we will plug in the values of x that we got here, -1, 0, and 1, to the equation that we have here. So that would be 1 over e raised to the power -1, which is pretty much e is equal to +1. And then this one is 1 over e raised to the power 0. Anything raised to the power 0 is 1. And then the next one right here is 1 over e raised to the power 1 is pretty much like 1 over e. So if we simplify this one comes out e raised to the power 1. So this is 2.72. And 1 over e is 0.37. Looking at the equation that we have here, our stretch factor is 2. So I'm going to multiply 2 to the f of x value that we got here. So I will multiply 2 to each of these, and this will be the resulting values. Now looking at the equation that we have here, this equation right here, not this one, it's this one, we can see that we have an x minus 3. So that we go ahead and switch it. So that would be x plus 3. And then we will use our transformed values for f of x using the stretch factor. That is 2f of x minus 5 because the k was 5. So these would be the values. So -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And then these values will be multiplied by 5. 5.44 minus 5 is 0.44. 2 minus 5 is -3. 0.74 minus 5 is -4.26. So we go ahead and sketch these values. Again, remember, these are the coordinates that we need so that we can sketch the graph. So I'm going to go ahead and sketch these coordinates that I have here. So this is the graph of this given function that we have here. Looking at this graph, we can say that the domain for this graph would be all real numbers. Now looking at the graph again right here, our range here would be values that are greater than -5. Now let's move on to the next example. This equation that we have right here can be written as, this tells us that our horizontal asymptote is y equals 3. Now please notice that this equation that we have here can be further rewritten as -1/2 1 over e, because that's e raised to the power -1 raised to the power x, and then that's a +3. So this will be the equation that we're going to use to complete the table of values. So I go ahead and draw the table down here. So the parent equation for this would be y equals 1 over e raised to the power x. So I'm going to go ahead and plug in these values of x here into the equation right here, and we will solve for y. Looking at the equation right here, our stretch factor is -1/2. So I will multiply -1/2 with f of x. So each of these values right here will be multiplied by -1/2 or -0.5. And this will be the values. So what I did was I multiplied each one of these by 1/2. So 2.72 times -1/2, 1 times -1/2, 0.37 times -1/2, and these are the values. Now looking at the equation that we have here, there is no h value, but then remember, we can add +0 or -0 there. It doesn't matter, so we can go ahead and write x plus 0 here, and then we're going to use this, that's -1/2 f of x, and then pair it up with k, which is +3. So I go ahead and fill the rest of these cells down here. These will be the values for x and y that we're going to use to sketch the graph. So this is the graph of this given function that we have here. Looking at this graph, our domain here would be all real numbers. And our range here will be values less than 3. So that is how we sketch the graph of functions involving the Euler's number e.